So I've been talking about this for a long time, but I'm going to convert this Lynx Power In into a distributor using some spare parts that I've collected. So in order to do this, you need some bolts, preferably some beryllium copper split ring washers, some standard washers, and some nuts of the right kind. These are, I believe, the M8. But first, I had to disable my system. So this relay, I'm now going to go to wall current. Okay. That now pipes power through here up into my various coolers and things. So you can see the green power there. That means my inverter is not being used and it's going to wall power. That means I can now disconnect my Victron energy. Also, it's kind of nighttime, even though it's still showing daytime. It's pretty much the sun is already going down. So it's time for me to disconnect my solar system from the Lynx Power In so I can do my thing. Okay, so I've removed that distributor. You can see my cable collection that's disconnected and my various tools. Now I'll go over here. You can see the various parts laid out on the table and the device under work here. Okay, so now I'm going to convert this. You will notice that I have gotten these various mega fuses. This is 250 amps. These are 200 amps. I'm going to just use these for 200 amp fuses in here for the conversion, because I don't see a need to support more than 200 amps. Even my 2 kilowatt inverter, I'm not sure I really want to go more than 250 amps. So maybe on that one I'll put the 250 amp on there and put 200 amps on the other ones, because the other ones are MPPT controllers and they shouldn't really be generating more than 60 amps unless there's somehow a short circuit through a cable, in which case I want the fuse to kick in. Okay, now I've got these screws. And I believe this is the last one for the conversion to be successful. There's the plastic part. And there we have it. Now, I've got these stainless steel M8 bolts. And I also have some regular steel ones, but I don't want these. These are M8 by 1.25 by 25 millimeter. That gives you the thread pitch in the length. So these are 25 millimeters long, 1.25 inch thread pitch, M8. And if I have done this right, these should line up exactly. The next part is this, but you don't want to just do this because you want the bolts to be protected on the underside as well. So if I remember correctly, this actually needs to have some washer action on the other side too. But I'm now going to, just to make sure I don't lose these parts, I'm going to kind of hand tighten. This is the one that's going to go to the inverter, so it's going to be bigger. It's a beryllium copper split ring washer. These are the ones that come with it. So when you get them, you want to make sure you use split ring beryllium copper split ring washers as well, and not regular steel washers. These two had the remaining 2 beryllium split ring washers, but they don't go here because I put them in the at the end when I reinstall this. So I've got myself some extra beryllium split ring washers. So these should be populating these 4. But I'm going to place one on the far end of each of these. Then I'm going to be placing an extra washer. Now, had some trouble finding stainless steel washers, so I just ended up getting regular steel washers. This will have some longevity issues, because in theory these could corrode. There could be some galvanic corrosion. So you have to choose based on what you're willing to accept for your galvanic corrosion immunity, for your long-term stability. I'm going to accept these steel washers instead of stainless steel washers. I'm going to place them this way though. Now I'm going to place the plastic back. These should now be snug. I'm not going now. The main difference between this hacked version of the distributor is that there's no circuit board, but that's okay because the circuit board in the distributor doesn't actually do anything except for light up some LEDs in the front to indicate a blown fuse, and that only works if you power it using the battery monitor circuit that does not come with it. So if you don't have that shunt battery monitor circuit, that circuit board isn't powered up anyway and doesn't do anything. So there's no difference between this and a distributor that doesn't have the shunt attached to it to power the circuit board. So this is not quite a full conversion because you don't have the circuit board, but I don't think Victron sells that circuit board separately. They're just trying to save their injection mold costs by making the parts as interchangeable as possible, which is a reasonable thing for a profit-motivated corporation to do. Perfectly legitimate action on their side. But it enables you to do this. Okay. Now to make this work, you basically have to make this the same height as this. And it's quite different because one of them has a bus bar and the other doesn't. So to do that, I will first add washers to protect the plastic. I will then add nuts. These are extra nuts that you need to buy. These are just M8. Now, these are stainless steel. Not sure if they're the same alloy. These are 304 stainless. I think the other ones might be 316 stainless. They're not quite the same, but they're close enough. Now I could add the beryllium washer under this, but I'm going to think about it. If I just do it like this, and then just put this across, I have to think about whether I want to add the beryllium washer or not. Or whether it's going to start creating a height difference if I add too many washers. So this currently works. So there's a washer, this goes there, then you put the next washer. This really should have a washer on top of it, one of these steel washers. And it's still good, so I think I will actually do that. This is the original beryllium copper. This is a spare beryllium copper. Now it's starting to lose its extra thread, so I may have to take a washer off. Perhaps the bottom washer. I may have to take that off. So I'm like losing too many threads on the bolt. Now, this is kind of unhappy because I really did not want to put this washer. You know what? Screw it. I'm gonna just put this directly on the bolt. To try to keep the threads intact. Okay. And I need that because this isn't done. This still needs to be able to support an additional element, which is the cable that comes on it. So I may have to thin it some more, especially with the thicker cable, with the inverter. So I'm going to always have this here, but I'm going to skimp on this side even more. Put the target cable here, then put a beryllium copper on top of that, and then nut on top of that, that might be sufficient. It will have to suffice for now. Okay, these other ones, I'm going to accept a 200 amp fuse. This one I want 250 because it's going to the inverter, and that inverter theoretically could draw. If it has a 4 kilowatt burst capability, so it could in theory actually draw more than 200 amps from these batteries. And the batteries are capable of sourcing that. I've got many lead acid batteries in parallel going into the battery power in, so it could easily source it. So I'm going to now put this one down there as the base. It's the doesn't have to be tight because that's I'm actually going to tighten against that. That's not structural. It's the nut itself that is going to be the structural point. Okay, this is a 200 amp fuse, and I know that because it says 200 on the blue plastic. Okay, this seems solid. And this beryllium copper spring washer goes here. And this future nut go here. And now I'm going to just repeat this over here, adding these additional fuse points here. These are going to also be 200 amp because these are going to 60 amp MPPT chargers. They do not need 200 amp fuses. They could have much smaller fuses. But I'm using these because I got a good deal, and in theory I might end up switching a high power inverter on one of these channels at some point. So 200 amp fuse is okay. And I don't actually want these fuses to ever blow anyway, and they're mostly for cable shorts. So here we go. Almost done. The only thing remaining is I've got some spares here. I've got a spare bolt. I could, in theory, do a future conversion of another unit if I really wanted to, or add another channel onto something. But I would have to start using some of these steel bolts instead of stainless steel bolts. So I was hoping to maintain galvanic compatibility by maintaining stainless steel, but that's really kind of BSy too, because these are just big copper, these are like zinc plated or copper bus bars anyway. So these are going to, there's going to be some galvanic corrosion in theory there. Anytime you have dissimilar metals in contact, you have galvanic corrosion, the possibility of galvanic corrosion. So it doesn't do you any good to have stainless versus steel. If it's touching a metal that's different from it itself, there will, over a period of many years, there will be galvanic corrosion. But anyway, there you go. I have now converted the Lynx Power In into a distributor. And it'll look like this when I close it up. But I'm now going to go mount it on the wall and put it back into action. Okay. This one is the most difficult cable to attach, so I'm going to attach it first. This is the high power inverter. this one connects down here. And this will go to the negative terminal down here. The positives are fused with these new fuses, or will be when I'm done with them. Should probably have removed them first before touching the cables. Washers that are in the way. There's the beryllium copper spring washer. Okay, these have to go this way, otherwise they won't fit. So they have to go back to back. Otherwise the connection is basically too thick. I'm not going to connect any of the positives until I'm done with all the negatives, just as a safety step. Okay, now I'm going to connect my two MPPT chargers. I'm actually tempted to also, because I only have two MPPT chargers and a load on this unit, I'm thinking of also moving my Victron charger to this as well. Because that kind of is more in the spirit of, right now I've got this Victron charger. Instead of running to the distributor, it's running to the power in. Or this is the hack distributor. So this one is okay, I never actually disconnected that one, so now I have to use this wrench. This one is still original unopened strength. Okay. Switch between these varieties of these tools here, because I had tightened that one pretty tight. Okay. Take the beryllium washer off, the beryllium spring. Okay. I'm going to now put the MPPT on there. The beryllium spring washer back. Then I'm going to put the nut back, hand tight. This is now fused. Again, this MPPT will never generate this amount of current, but this is just a safety mechanism in case of a short circuit somewhere in the system. Okay, next one. Let's take the beryllium washer off. Okay. Now, this is going to be my second MPPT charger running to the same battery bank. Put that under these red cables here. So now I'm going to add the beryllium washer, and now the nut. So 2 chargers, 1 load, and 1 unused. So let's fix that unused issue. Why do I have the charger connected to my battery side? I shouldn't. I should only have chargers and loads connected on this distributor side. Okay, I've opened them both up now, the cover plates. So this Centaur is currently connected here, which is connected to a bunch of batteries, but really that Centaur should go to there. So I'm going to move that over, and it's now going to be fused as well. That should never generate more than 60 amps, so that 200 amp fuse should be plenty. It's only to protect in case of a short circuit there. Okay, I've restored the shell on that side. I'm now going to add the Anderson connector on this side because I want to disconnect the Centaur on the loads and chargers side, which is more appropriate anyway, being in the spirit of you should have your batteries on one distributor and your loads on the other. Plus it's now fused. The battery side is not fused. That is a subject of debate among people regarding safety. It would be better if the battery side is fused, but maybe it generates some small voltage gradients when the batteries are trying to equalize with each other. And I've heard arguments on both sides for, hey, this side's better, that way is better. It's not clear to me which way is better. Although I suspect probably having fuses is better than the small error in the voltage equilibration caused by the fuse. But nevertheless, I'm not putting fuses there. So really, you're better off, for safety reasons, to fuse the batteries. So a power in shouldn't exist from that logic. Everything should be distributors. So Victron should not sell power ins at all. Everything they make should be distributors, both on the left and right side of the of all their units. So that's obviously not what happens. So maybe you shouldn't have to be so worried about it. Okay, I'm just gonna put this here. Just want to make sure I have enough threads remaining for a washer. It's kind of thin, it's on the dicey side, so I think I'm going to just attach this. I don't like it. I think those bolts should be a little longer. I'm going to attach this like this. perhaps these bolts should be a little longer, but there it is. The Centaur is now connectable. I won't connect it yet though. I'm now going to connect the first MPTT. This is technically only a 20 amp MPTT. So this cable is really kind of oversized for it. But that's, and it's got a 200 amp fuse. So a 20 amp MPTT with a 200 amp fuse. Again, the main purpose of that fuse is to protect against short circuits in the cable. Not really anything to do with the MPTT. It's a severe mismatch in size. So obviously nothing to do with the MPTT itself. And when I connect this should light up that MPTT. I'm going to first flip this cable around a little bit, and I'm going to pass it around under these. And then I don't have enough threads, so I'm going to have to skip the washer, which is really bad, but there just aren't enough threads. I think the bolts, I will have to put longer bolts someday. And I have some washers in there. And there you can see that the MPTT has indeed energized through that fuse. And I have removed one of the beryllium split ring washers. This one is now the 40 amp MPTT. Funny enough, my 40 amp MPTT actually has a thinner gauge wire coming from it, but it's a higher purity cable, so higher quality wire. Even though it's thinner, it's still good. Let's see a little bit of a spark there, so it's probably charging some capacitors in the MPTT. It's on the receiving side though. And no surprise there. Now that one is energized too. And last but not least, it's now time for the high power circuit. This one is the high power inverter. This one may generate a big spark because these often have large capacitor plates as a pre-filter or part of the circuit in the function. So I would not be surprised if I see a spark. I'm going to touch it. Yep. Even if it's off, it still generated that spark. I've intentionally kept it off. Fortunately, the breaker or the fuse is slow blow. Otherwise, if it was a fast blow fuse, it might have actually would blow the fuse because it's basically probably a large current there, charged capacitor. There it is. The inverter is running now through there, through that fuse, but now with the safety of an additional fuse. I'm actually going to add these black plastic wire guides back. I think these mostly just exist to give you a sense of security so that the cables can't short circuit on each other as easily, but I don't think they actually do that much. So I'm going to just kind of pop them back on, and in order to do that you have to actually loosen some of the screws a little bit. And now there's a physical plastic separation between the power lines. So you can rest assured that there's no way you can get a short circuit in an easy fashion. I'm not sure if it really does anything really, but it does give you a little bit of more sense of security. And now there we are to the, those are charged up, the inverter is powered, and I can now close up the plastic cover again. This is now effectively a Lynx Power In converted into a distributor. Okay, now I'm going to reattach the case, protective shell, these annoying screws. They never quite go in right. Not sure why. This is like the worst part of the Victron system. It's these dinky little plastic screws on the end. I mean, they're retained with springs to help keep you from losing them and everything, which is a nice touch. They don't quite always work right when you want to just put the cover back on. That's much better. It was just, I think, aligned incorrectly. Probably user error on my side. And when they start cinching up, tightening up, plastic case goes back to its original alignment, and you know you're done as much as now it's tight. And now finally it's done. The lights don't light up because there's no PCB inside. But even if there was a PCB inside and that was a real distributor, the light still wouldn't light up because you need to have the shunt. The shunt has the control circuitry that energizes that PCB. So this is now effectively as if you had put a distributor instead of a power in. Fused protection. Here's an equivalent circuit, except this time it's a real distributor. See, no lights either because no shunt to power the PCB. And there it is. Your hack conversion is done. And various parts. You need some beryllium copper springs, some mega fuses, some bolts. Perhaps a slightly longer bolt might be useful. As you can see, I was running out of bolt length there. Or perhaps if I had used lower profile nuts, that might have helped too. I somehow think that the nuts that they provide are actually like machined down or something. They're a little thinner or something because they don't quite look the same. I think that might be how they do it. So anyway, there you go.